This topic is about a different measure for working with angles, and this is using radians. We need to be able to convert between degrees and radians and vice versa. We need to be also solve problems involving radians using the formula for arc length and sector area. Feel free to pause as I go through concepts and examples. First of all, we need to go through the definition of a radian. So if we have a circle of radius r, then a radian is an angle enclosed by two radii, so we have two radii here, and an arc length, which is a section of the circumference, equivalent to r as well. So this is 1 radian. So you have two radii coming from the center, and then the arc length is also equal to the radius. So it is a unit of measurement of angles equivalent to the angle subtended at the center of a circle by an arc equal in length to the radius. Okay, so that is 1 radian. Okay, what we need to know is how many of these radians fit throughout the whole circle. So that's what we're going to investigate first. So we have a circle with radius equal to 1 unit here. So if I change the angle, you can see how much of a radian this is. So if I go all the way up to 1 radian, that's 1 radian. So you can see it's an acute angle. Now what I want to do is how many of these radians fit through the whole circle. So if I go to half the circle, oh, it looks like it's somewhere close to 3.15, which is a familiar number, which is roughly pi. So it looks like 180 degrees is about pi radians. So if I go all the way around, all the way up to 360, it's about 6.25 here, so it's a bit more. It's about 6.28, so it looks like it's 2 pi. So no matter how big or small I make the radius, you can see it's 1, 2, 3, 4, 5, 6 and a bit, 6.28 radians make up 360 degrees. Now, given this information, we do know that 2 pi radians, because 2 pi of those radians fit through the whole circle, must be equal to 360 degrees. Okay, another way of writing 2 pi radians is 2 pi c. Okay, c means radians, it's measured in radians. In a similar way, because we can divide by 2, that means pi radians is equal to 180 degrees. So that is pi radians. If I wanted to find out what 1 radian is equal to, so 1 unit of radian, so 1 radian, all I need to do is divide the second line by pi. So it's the same thing as 180 degrees divided by pi, which is approximately 57.3 degrees. Okay, so this is what you need to remember, that 2 pi is equal to 360, or I prefer to think of it as pi is equal to 180 degrees. Okay, so first thing we need to be able to do is convert between radians and degrees. Now, looking at these facts, if I want to go from degrees to radians, it means I first need to do, I'm going to look at this one, which is 180 degrees is equal to pi radians. That means I need to divide by 180 and times by pi to get into radians. If I'm going to go from radians to degrees, I need to divide by pi and times by 180. So let's put this into practice. So if I want to look at 140 degrees in radians, what I need to do is I need to do 140 divide by 180 and then times by pi. Now if I simplify, I get 14 over 18 pi, which can be further simplified to 7 over 9 pi. If you want to write radians, you can write C there, or you can just leave it as 7 over 9 pi. Okay, 20 degrees, so again, I need to divide by 180 and times by pi. If I divide top and bottom by 20, I just end up with 1 over 9 pi radians. 330 degrees in radians is 330 divided by 180 times by pi, which is equal to 33 over 18 pi. There's a common factor of 3 throughout, so it's 11 over 6 pi radians. Okay, if I want to go from radians to degrees, then I need to do 5 pi over 8 divided by pi times by 180. All that means is the pi and the pi cancel out, which means I'm left with 5/8 of 180. Okay, that works out to be 225 over 2. Now, when we're working with degrees, we prefer to write it in terms of decimals. So that is 112.5 degrees. Okay, 3 pi over 5 is the same thing as 3 pi over 15 divided by pi times by 180. So the pi and the pi cancel out. 3 over 5 is a fifth of 80. A fifth of 180 is 36 degrees. Again, 7 pi over 6, if I want to write it in radian form, 7 pi over 6 divided by pi times by 180. Okay, so I have to do 180 divided by 6 times by 7. So 180 divided by 6 is 30. 30 times by 7 is 210 degrees. So you need to be able to go from radians to degrees and vice versa, because the next set of formula, you need to make sure the angles are always in radians for this. Okay, so arc length and sector area. So here we have a circle of radius r going from the center O to 2 points in the circumference A and B. Okay, then the arc length is L, which is a section of the circumference, which is going from A to B, arc length. And the area of sector is that part that I've just shaded in. Okay, first formula that we need to derive is the arc length formula, and it's derived using proportions. So what we do know is the length as a proportion of the whole circumference. The length over the circumference must be equal to, if we call this angle theta, theta over the whole angle of the circle, which is equal to 360 degrees normally, but in radians it's 2 pi. And the circumference of a circle is equal to 2 pi r. So using circumference is equal to 2 pi r, it implies we get L over 2 pi r is equal to theta over 2 pi. Okay, because we've got 2 pi in the denominator for both, we can cancel it out, which means I've got L over r is equal to theta, which means L is equal to r theta. And that is my formula for arc length. Now the important thing is theta must be angle in radians, because when we were deriving this formula, we used 2 pi, which is in radians. Okay, now if I do the same thing, a similar thing for sector area, let's call this A, or AS, yeah. Then if I, as a proportion, the sector area over the area of the circle, the proportion of that must be the same thing as theta, which is the angle of this sector area, over the whole angle of the circle, which is equal to 2 pi. Now using, again, area of a circle is equal to pi r squared. This implies sector area over pi r squared is equal to theta over 2 pi. Again, we have a pi in both denominators, so I can get rid of it, which means sector area over r squared is equal to theta over 2. If I rearrange it, I get sector area is equal to theta over 2 times r squared. And we prefer to write it as area, which is defined as sector area, is equal to half r squared theta. So that's the sector area formula. Again, for both of these, theta has to be in radians. Okay, so the angle must be in radians. This is not given in the formula booklet. So these two formulae. You need to memorize these and use this obviously when problem solving with circles. Okay, so again, angles need to be in radians and they're not given in the formula booklet. Okay, let's go through some examples where we use these formulae. Okay, so work out the arc length AB. Okay, so we're trying to work out the arc length AB. So let's label it. So this is my arc length AB. Okay, A using L is equal to r theta, where r is equal to 5 centimeters and theta is equal to 0.6 radians. So it's already in radians and you don't need to convert it. Then L is equal to 5 times 0.6 and 5 times 0.6 is equal to 3. So L is equal to 3 centimeters because my units were in centimeters. Okay, part B is the area of sector AOB. So I'm trying to work out this sector. Okay, again, now using the formula for sector area, A is equal to half r squared theta, where r is equal to 5 centimeters and theta is equal to 0.6 radians. I get A is equal to half times 5 squared times 0.6. If I put that into my calculator, I get A is equal to 7.5 centimeters squared. Okay, next question. It says work out the perimeter of the shaded region R. So I'm trying to work out first this part and then this part. Add it together to get the perimeter. So for A, first I'll work out L, which is arc length. So using L is equal to r theta, where r is equal to 5 meters and theta is equal to 1.5 radians. Then I have L is equal to 5 times 1.5. Oops, 1.5 I should write. Which is equal to 7.5. Units are in meters, so that's 7.5. So L is equal to 7.5. Okay, now I need to work out this length here. Now, there's lots of ways of working it out, but I prefer splitting this triangle into two and then working out what this is. Let's call this M. And what I do know is this consists of two M's, obviously. So if I draw my triangle out, so then it's a right angle triangle here. I'm trying to work out M, which is there. I have this is 5, and because this is split in two, this must be 0.75. So I know I can use trigonometry, SOHCAHTOA. I have opposite and hypotenuse. So using sine theta is equal to opposite over hypotenuse, then I know that sine of 0.75 is equal to opposite, which is M, over hypotenuse, which is 5, which implies that M must be equal to 5 sine 0.75. Now use your calculator in radian mode. It gives me a value of M is equal to 3.408 blah blah blah. So now if I want to work out the perimeter, I know the perimeter of the whole shaded region is L plus m plus m, which means I've got 7.5 plus 2 lots of 3.408 blah blah blah, which gives me a value of 14.32 to 2 decimal places, and because the units were in meters, the perimeter must also be measured in meters. Okay, part B, work out the area of the shaded region R. Okay, because I want to work out R, for B, it must be area of the sector. So area of the sector, take away area of triangle must be equal to area of the little bit that we want, which is R. Okay, so let's work each one out separately. So the area, undo. So the area of the sector is equal to, the formula is half r squared theta. In this case, my r is 5, so half 5 squared, and my theta is 1.5, which gives me a value of 18.75. Now I need to work out the area of the triangle. Now, area of the triangle, which is this bit, okay, I can use half AB sine C because I've got 2 lengths and an angle in between. So half AB sine C is half times 5 times 5 times sine 1.5. Again, in my calculator, I need to make sure I'm in radian mode. So I get 12.468, blah, blah, blah. So now if I want to work out the area of R, all I need to do is area of sector, which is 18.75, take away the area of the triangle, which is 12.468, blah, 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 which gives me a value of 6.28131, blah, 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 which is 6.28 to 2 decimal places. And because the lengths are in meters, the area unit is meters squared. Okay, next question. The diagram shows a sector OAB of a circle of radius 9.2 and center O. Given that the area of the sector is 37.4, find to 3 significant figures the size of angle AOB in radians. Okay. So given the area of the sector is 37.4, so area is equal to 37.4 centimeters squared. So using A is equal to half r squared theta, I get the area, which is equal to 37.4, must be equal to half times radius, which was given to us. Radius is equal to 9.2 centimeters. So half times 9.2 squared times theta, which means 37.4 must be equal to 42.32 theta. Theta must be equal to 37.4 over 42.32. In my calculator, I get an answer of 0.8837, blah, blah, blah. Which means if I work it out to 3 significant figures, I get 0.884. Again, this is in radians, so radians. Okay, part 2, find the perimeter of the sector. Okay, so that means perimeter means I need to work out this side, add it to that side, add it to that side. Now I do know these two are 9.2. All I need to work out is L. Okay, so using L is equal to r theta, I get L is equal to 9.2, which is the radius, times theta, which I've just worked out, which is 0.8884. 8837 blah blah blah. I will be using the non-rounded version, which gives me L is equal to 8.13043. Okay, now the perimeter is equal to 9.2 plus 9.2 plus 8.13043 blah blah blah, which means it's equal to 26.5304. If I round this to 3 significant figures, I get 26.5 as perimeter, and the units are in centimeters, so the answer will be centimeters, 26.5 centimeters. Okay, next question. The diagram shows the sector OAB of a circle, center O, in which angle AOB is equal to 2.5. Given that the perimeter of the sector is 36, find the length OA. The length OA is just the radius, okay? So that's what we're trying to find out, the radius. So first thing we do know is the perimeter is equal to 36. Now in this case, the perimeter of the sector is just R plus R. So this plus this plus this, which is the arc length. Now the arc length is measured as R times theta, which is just R times 2.5. So it's just 2.5 R. So perimeter in this case is equal to also R plus 2.5 R, which is equal to 4.5 R. So if I equate these two things, then I get 4.5 R must be equal to 36. So R must be 36 divided by 4.5, which means R must be equal to 8. Because the units of the perimeter was in centimeters, the radius is in centimeters as well. Part 2, find the perimeter and the area of the shaded segment. Let's work on the perimeter first. Okay, so if this is L, let's label that as L, then using L is equal to 2.5 R, that must be 2.5 times 8, which is equal to 20 centimeters. So I know this part is 20. Okay, now if I split this triangle up again and work out this part, which is M, then if I have this triangle, the radius is 8, we've just figured it out. This angle is half of 2.5, which is 1.25. And this is M. Then I've got opposite and hypotenuse. So using sine theta is equal to opposite over hypotenuse, I get sine of 1.25 is equal to M over 8, which means M must be equal to 8 sine 1.25, which means M must be equal to 7.5918, blah, blah, blah. So I want to work at the perimeter of the shaded area. Then that would be this part we have just which I've worked out already, which is equal to 20 plus M, which I've just worked out, which is 7.59, plus another M there. So I've got 2 lots of M. So I've got 2 lots of 7.5918 blah blah blah, which gives me a value of 35.1837 blah blah blah, which is 35.18. The units were in centimeters, so 35.18 centimeter. Now to work out the area of the shaded, so area of shaded segment is equal to area of sector take away area of triangle. So you can see if you do that part take away this part, you'll end up with the shaded part. Okay, so first thing I need to work out is area of sector. So area of sector is equal to half r squared theta, which is half times 8 squared times theta, which is 2.5, which gives us a value of 80. Area of triangle is equal to half r squared sine theta. It's r squared because it's half AB sine theta, and A and B are both r. So I end up with half times 8 squared times sine of 2.5, and I get a value in my calculator, making sure I'm in radian mode, 19.1511, blah blah blah. So area of shaded segment is equal to area of sector, which is 80, take away the area of the triangle, which is 19.1511, which gives me a value of 60.84889, which is equal to 60.85. Units were in centimeters, so unit of area is centimeters squared. Okay, another example. Referring to the diagram, find the perimeter of the shaded region when theta is equal to 0.8. Okay, so when theta is equal to 0.8, then let's call this L and let's call this M. So L will be equal to r times theta, and the radius for L is 3 times 0.8, which gives you 2.4 centimeters. M again is r times theta, but the radius for that one, for M, is 3 plus 2, which is 5. So it'll be 5 times 0.8, which is 4 centimeters. So if I want to work at the perimeter, it will be 2 plus 2 plus L plus M. 2 plus 2 plus M plus L, which is equal to 2 plus 2 plus 4 plus 2.4, which is equal to 10.4 centimeters. Okay, part B. The value of theta when the perimeter of the shaded region is 14 centimeters. So we know the perimeter is 14. Now the perimeter of the shape is equal to 2 plus 2 plus L plus M. But that's the same thing as 2 plus 2 plus L is just 3 theta. And M is just 5 theta. And that must be equal to 14. So 4 plus 8 theta is equal to 14, which means 8 theta must be 14, take away 4, which is 10, which means theta must be equal to 10 over 8, which is equal to 1.25 radians. A sector of a circle of radius 15 centimeters. So let's just draw it out. We've got a circle with radius 15 centimeters. Contains an angle of theta degrees. So this is theta. Given that the perimeter of the sector is 42 centimeters, find the value of theta. So the perimeter is equal to 42 centimeters. So what I do know is this is 15 and that is r theta, so this is 15 theta. So the perimeter is also equal to 15 plus 15 plus 15 theta. So if I equate the two, I've got 15 plus 15 plus 15 theta is equal to 42, which means 30 plus 15 theta is equal to 42, which means 15 theta is equal to 42, take away 30, which is 12. So theta must be equal to 12 over 15. So theta must be equal to 0.8 radians. Okay, I would like to summarize a few points. Okay, so the two formulae that you need to memorize is L is equal to R theta and A is equal to half R squared theta. You need to memorize these, so you need to memorize, not in formula booklet. And they are the formula for arc length and sector area. Angles need to be in radians always in order to use these formulae. Other formulae that you might need, so other useful formula is SOHCAHTOA is useful, sine rule, cosine rule, and area of triangle rule. Know how to go from radians to degrees and vice versa. So the main thing to remember about that is 180 degrees is equal to pi radians. And the other thing you need to know is if you have a circle with the angle theta, then this one, the smaller arc is called the minor arc, and the bigger arc is called the major arc. Okay, so if they say major arc, go for the big one. If it's the minor arc, go for the smaller one. So major arc is bigger than minor arc. Okay, so try to memorize these things, and then it'll help you to solve problems when you're working with radians and circles.